Here we have another What the Physics video. This one is on graphing. Graphing, good stuff, good stuff. Let's do the learning target. Learning target says, I can read, interpret, and create a position versus time graph. Oh yeah, oh yeah, I'm feeling good about this. Sounds like a lot of fun. All right, so remember, when we had first learned about velocity, we said velocity is displacement divided by time, the delta d over delta t. And if we expand out the deltas, we get d2 minus d1. And then down here, it's in the denominator, t2 minus t1. Now, we also called it final minus initial, but it's really the same thing. We can say d final minus d initial or d2 minus d1. The reason I'm setting it up like this is because I'm wondering, does this equation look familiar? Wait a minute. Wait a minute. The equation for slope is super duper similar to this. It's y2 minus y1 over x2 minus x1. Oh my goodness. What does that mean? What does that mean? Well, if we say velocity is the displacement over time, or divided by time, what we're really saying is if we have a position time graph and I divide, or I take the slope, I am getting velocity. So the slope of a position time graph is the velocity. Ooh, that's pretty cool stuff. I like it. I like it a lot. Let's take a little closer look at our position versus time graphs. Okay, so let's make a little graph. And we've got position is going to be here. Sometimes I'll say D, sometimes I'll say X. It's kind of weird when I refer to position as X and I'm referring to it on the vertical axis because people are used to thinking, oh, that's not the X axis, that's the time axis. Or excuse me, that's the Y axis. That's not the X. Yeah, this is not the X axis here at all. This is the time axis and this is the position. Whether you call it D or X, doesn't really matter. It's position. Okay, anyhow, so we've got a situation here where we are moving, whether we're running, whether we're walking, whatever it is, we're moving at a nice constant velocity. We started out at position 0, and then we go up to some position up here. We're not really using numbers. I'm just going to say D1. Okay, so if I want to know what my change in position is, it's final minus initial, D1 minus D0. That's my delta D. And of course, my time interval is T1 minus T0. That's final minus initial. For the second part here, what are we doing? What are we doing? Time is passing, but are we moving on the vertical axis? No. What does that mean? That means we're not moving at all. We have no change in position. That means my velocity is 0. Time is passing, but my displacement, d1 minus d1, is 0. So, okay, yeah, sure, that makes sense mathematically and hopefully in terms of physics. And then how about this? How about this? Well, I was up here and now I'm down here. So my final minus initial positions is going to be d0 minus d1. So I have a negative displacement. I have a negative displacement. That means because change in time is always going to be positive, I'm going to have a negative velocity. And if you look at this, I have a negative slope. You say, oh, all right. Negative slope of a position time graph does mean negative velocity. I like it. It's physics. I want to be friends with this stuff. This is good. This is good. Hopefully it makes sense. Let's keep going. So what can we do with the graph? Anytime you see a graph, you should be asking yourselves a few questions. See, first of all, a graph is not just a lovely picture. It's not just a pile of data. It does show a lot of information, but you got to understand what that information is all talking about. And it's not just the individual stuff on the vertical axis. It's not just the individual stuff on the horizontal. It's how these compare. Okay, you think about a graph, there's 3 things you can do to a graph, 3 operations, 3 functions that you can do to a graph. The first one is just reading as is. You just read a graph as is. That's something you've probably been doing for like 10 years. Since you were back in elementary school, you read what the graph tells you. You say, oh, at this time, my position is this. Okay. Or it was probably even more simplistic. You said, how many beans are in this cup? Or how many people are this tall or something. But you're just reading it. You're not really doing much in the way of operations. You might be doing some basic subtraction to see a change in, but that's it. That's read as is. The next one is taking the slope. You've been taking slope for several years now. All that Algebra 1 stuff, and probably before Algebra 1, you've been taking the slope. The rise over the run, we just talked about that. The slope, remember, is a new concept. Remember, the slope of a position time graph is velocity. So we are introducing a new concept here. The slope is the rate of change between the two variables. And then the third thing that we can do is take the area under the curve. And the area under the curve is probably something you haven't done much in math yet. But you certainly have done areas for quite some time. And all we're going to be doing is sticking with triangles and rectangles. So let's say we've got we've got a rectangle here, okay? We'd say this is the base and this is the height, and we're just going to say the base times height, right? If we have a triangle, what is the formula for the area of a triangle? Well, that's going to be 1/2 base times height, okay? Because it's half of the rectangle, right? We have the rectangle, we kind of chopped it off, right? Okay, we'll see what that means as we get farther along. But we do recognize this. Now, some of you that are in the more advanced math classes, you might recognize this and you say, wait a minute, Fair, are you talking about derivatives and integrals? Yeah, kind of am. Folks that are not in more advanced math classes, they might be like, whoa, whoa, whoa. Hey, slow down there, boss. Slow it down. Hey, I'm just using the words here and there just to show that how they relate. If you haven't learned about derivatives and integrals yet, don't worry. You'll get there. It'll be awesome. And you'll be like, oh, I did this already. I did physics. Yeah. All right, so what information do I want from the graph? The first thing you need to do anytime you see a graph is you got to ask yourself, what type of graph do I have? And I don't mean, oh, it's a bar graph, it's a pie chart, it's a line graph. No, no, no. I mean, generally speaking, it might be a scatter plot or a line graph. But the important part is what type of graph am I dealing with? We'll get to that on the next slide. The next question is, what is being asked for? As in, read the question carefully. The third question you have to ask yourself is, which operation am I going to use? And that was the list of operations was on the previous slide. Okay, so let's figure out what type of graph I have. How do I know what type of graph this is? We say, oh, it's a line graph. No, 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 that's not what we're talking about. We're talking about what variables are being compared on this graph. So how do I know what type of graph this is? Well, you can look at the title. It's an acceleration versus force, because it says that right there. Okay, now graphs don't always have titles being shown. So what else can you do? Sometimes they're sloppy and they don't include the titles. You can look at the axis labels. And we just do a y versus x, yeah? Vertical versus horizontal, acceleration versus force. Okay, cool. What else can you do? Well, if they're not labeled, you're not likely to have the units. But assuming you do have the units, you can always kind of use them as a good starting point. Okay? Meters per second squared, that's going to be for acceleration. Newtons, that's going to be for force. Okay, so let's do a graph. What type of graph do I have? Of course, I have a position time graph. How do I know? It says position time. It also has position and time written up there. Lovely, lovely, lovely. Let's get the graph going on here. Okay, so I've got some different lines up in here. And I want us to think about how I can describe this line right here. I mean, it's diagonal. But what else can I say about this? I have, this is the position, remember, and this is the time, so we're focusing on that. Am I moving? Well, yeah, I am moving. I was at position 0, then I'm at position 10. I'm not going to focus on the numbers too much, but I can tell you that I have a positive motion. Positive motion, okay? And that means I'm going to have a positive velocity. Positive velocity. I know the velocity is positive because I know the slope of this line is positive. Remember, it's a position time graph. The slope of the position time graph will give me the velocity. So if the slope here is positive, that means the velocity is also going to be positive. So what can you tell me about this line here? Well, I don't seem to be moving. My position is still at 10 meters the whole way across. And my slope here is what? It's flat, so my slope is going to be 0. That means my velocity is 0. So, okay, sure. Line 3 is another diagonal line, but notice line 3 is steeper than line 1, so keep that in mind. So the slope is positive because it's like we're going up the hill. So if the slope is positive, that means my velocity is positive, and I have a positive motion. Not only that, but what can I say about the steepness of the slope here? We said it's a steeper slope here than here. So if this slope is steeper, and remember the slope of a position time graph is velocity, then that means the velocity is larger. I have a larger velocity here. I could calculate the numbers, but we'll do that later on. And then finally, oh, here's the click. And then number 4, line number 4, what can you tell me about this? Well, my slope is negative, which means my velocity is negative, which means my change in position or my displacement is going to be negative. Physics, I like it. Good stuff. Let's keep going. Here's that same graph. Now I'm asking you questions that are more mathy in nature. So it says, what is the speed during the first 20 seconds? So once again, we're dealing with the, oh no, what's the title? Oh no, what type of graph? Well, there's no title, but it does say position and time, right? So it's a position versus time graph. Strategically took out the title this time so you could use the axes. It's a position versus time graph, and I want to get speed. So how am I going to get speed or velocity from a position versus time graph? Oh, I take the slope. Hey, yeah. I'm going to take the slope of this for the first 20 seconds. The rise over the run. Make sure when you're looking at this, you're actually looking at the numbers and not just counting up boxes. You say, oh, the slope, I go up 1 and over 1. No, you goose. Okay, I go up 10 meters and I go over 20 seconds. 10 divided by 20 is 0.5, and meters divided by seconds is meters per second. So my speed or my velocity, but I was asked for speed, is 0.5 meters per second. Number 2, how far is the object from the start after 60 seconds? So once again, I have a position time graph. In this case, I'm looking for my position or my change in position after a certain time. So I'm just going to read it as is. I'm not going to be taking the slope here. So at 60 seconds, my position is 40 meters. At 0 seconds, it was 0. So that means my change in position is final minus initial. 40 meters minus 0 meters. Boom, 40 meters. Number 3, what is the speed during the last 40 seconds? Okay, well, let's see. It goes up to 100, so we must be talking from 60 to 100. Well, what type of graph do I have? Position versus time. What am I looking for? The speed, which is like the same way I get velocity, right? I'm just not going to be paying attention to the sign. So what do? I take the slope. Oh yeah. Oh, too much. I take the slope. So taking the slope of this position versus time graph, it is going to be a negative, but as we said, I'm asking for the speed, so we'll drop that. It'd be 0 meters minus 40 meters, that'd be negative 40. And then divided by 100 seconds minus 60 seconds, that's 40 seconds. Okay, so negative 40 meters divided by 40 seconds gives me negative 1 meters per second. But I'm asked for the speed, I'll keep clicking by accident. I'm asked for the speed, so I'm just dropping the negative sign. It's just moving in one direction, so that means the speed and the velocity would be the same, except for the velocity would include a particular this way, that way, in this case, like negative. Okay, and then number 4, when was the object traveling the fastest? When was it traveling the fastest? Well, it's a position versus time graph. So when has it covered the most ground in the least amount of time? You say, oh, let's see. Another way of saying this would be, when is the velocity the largest? Or more to the point, when is the slope the largest? Largest slope, steepest slope, right here, right here, right here, right here. Delicious. Now, a word of caution about how you describe graphs, and not only the graphs, like what the graph is doing, but also the slope of the graphs. If you look at these two lists, constant, increasing and decreasing, and then 0, positive, and negative. These are two separate lists, and you can describe any graph for a particular section with one word from this list and one word from this list. Notice you can't be 0 and positive at the same time. You can't be constant and decreasing at the same time. But constant, a lot of people will often confuse constant with 0. People will confuse increasing and positive, decreasing and negative. You shouldn't. They do not equal each other. You can have a constant velocity that is 0. You can have a constant velocity that is positive. You can have a constant velocity that is negative. You can have a velocity that is increasing going through these. You can have a velocity decreasing going through these. You can have a positive velocity that is constant, increasing, decreasing, and so on. Okay, so you choose one from this list and one from this list. This list is kind of describing what the object is doing. This one is describing like a potential change. We'll see what that means in a few when we actually get to describing actual graphs. Okay, so to help us with that, we have a guest lecturer. Maybe. There we are. Replace the words. Courtesy of strawberry shortcake. Okay, now you might be saying, what are you talking about? Let's watch this video. Boom, right up there. Okay, so this is kind of a wacky video, but it does also help you.
We're going to try an example of taking a displacement versus time graph and creating from it a velocity versus time graph from the example graph shown here.
Shortcake.
Now our first step might be to break this distance versus time graph into some more manageable chunks. So
this is just a setup that someone had drawn in. I don't think you should have nearly as many curves as he had drawn in, but we'll kind of go ahead and jump a little bit. Okay, so he's drawing off little sections.
Around here.
Now would be a good time to pause the movie and try it yourself. Have you tried it yet?
Huh?
Have you?
This I'm singing out for a full hero. Okay, so once we have these...
Weird. I don't know what was going on with strawberry shortcake there, but once again, it just cracks me up. So what he has done is he's split up the graph into the different sections, and he's going to be talking about, oh, this section right here, this section here. What are we doing?
Divisions broken up, we can start the graph. So remember, we're graphing down here the slope of this graph. So at the beginning, this D starts out pretty steep. So for our velocity, we can start a pretty high velocity, maybe around here somewhere. Then over time,
the idea is the slope of this position time graph is going to give us velocity. So the slope here, remember those words we had before, the slope is positive. So that means my velocity is positive. And then from the other list, the slope is, what is happening to the slope? Slope is decreasing. Started off nice and steep, now the slope is getting smaller and smaller. So that means the velocity is going to be positive, but getting...
time, the slope gets less and less steep. And in fact goes to 0 at this point here. So we'll try and draw that something maybe like this, where the velocity is at 0, where the slope in the distance graph is 0. After that, we go from a 0 slope to a slightly positive slope, more positive.
Okay, so the slope here, well, was 0. Now the slope is positive, Slope is positive, slope is positive, 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 this whole way up. But what is happening to the slope? The slope is 0, and now slope is increasing, increasing, increasing. And then later on it will decrease, but that's a separate section.
Positive slope, most positive around this area here, and then we have a decreasingly positive slope up to 0 at the top. So we can try and draw.
So if the slope is, the slope of the position time graph is positive and increasing, that means our velocity will be positive and increasing. And then later on, it'll be, the slope is positive and decreasing, so the velocity will be positive and decreasing.
Draw that, where we start at 0. We go from 0 to a more positive value, to a maximum around here, then we still say positive, we go back to 0.
Strawberry Shortcake says 0 slope means 0 velocity.
So after this, we now start to have a 0 slope going to a negative slope.
Optimus Prime says that a negative slope means a negative velocity.
So you have to show that, and we kind of reach a...
So we have this was 0, we have a negative slope, so that means my velocity is going to be negative. So we're going to be drawing down here. So the slope of the position time graph is negative, which means my velocity is going to be negative. The slope of the position time graph is also, we're getting steeper and steeper, steeper and steeper. The slope is increasing. You say, oh, but it's negative. Yeah, still increasing though. Okay, so that means the velocity will be increasing. Negative, but it will still be going faster and faster. So I mean, if we're getting farther and farther away from the horizontal, that means increasing.
The maximum negative slope somewhere around this area here. So we start at 0, we get more and more negative, we get to a maximum negative, and then we actually kind of peter out and kind of go back to 0 at the end of this pink line. So we have a very negative slope here, and then we're kind of getting to 0 down here. I could have even made this probably flatter, almost like that, where I go down, kind of flatten out, I'm almost 0 for a while, and I kind of come back.
So yeah, I think it would have been much better if he actually drew out like straight lines or more clearly curved lines or whatever, but you know, it's still good stuff.
So here I have constant slope here, but the slope here is actually 0.
Strawberry Shortcake says 0 slope means 0 velocity.
So this whole section makes a 0 velocity. So you can draw a 0 velocity term going along here.
That line isn't very straight.
That's almost a straight line. Okay, there we go. There's approximately 0 velocity.
That's still not very good.
And then right here, we go from 0 velocity here, 0 slope here, to a pretty positive slope over here.
Elmo says positive slope equals positive velocity.
So let's show...
Okay, and this continues on. To give credit where credit was due, it was made by someone called Physics is Cool, and it was made back in 2008, and there you go. It's called Drawing a Velocity versus Time Graph. Okay, dip that away. But my takeaway here is the slope of a position time graph equals velocity. So what we can remember here is on a position time graph, Strawberry Shortcake says 0 slope means 0 velocity. And then on a position time graph, you have to keep emphasizing on a position time graph, Optimus Prime says negative slope means negative velocity. That's not really what Optimus Prime sounds like, but that's how he made it in this recording. And then finally, Elmo. Ugh. On a position time graph, Elmo says positive slope means positive velocity. So these are just silly little things. As long as we can, if we use these voices, that will really help us remember about the slope, the 0 slope, negative slope, and positive slope. On a position time graph relates to how we would draw the velocity slope, because remember our learning target was I can read, interpret, and create a position versus time graph. Okay, and then how we go from a position versus time graph to a velocity versus time graph. Yeah, physics.